Hello everyone, in this video, I'll be guiding you through the creation of a powerful, AI-driven application that analyzes and extracts detailed information from any uploaded image. Using Streamlit, Python, and the NVIDIA NIM API, we'll explore how to harness the capabilities of leading image understanding models like Microsoft's Kosmos-2, Adept Fuyu-8B, Google's Paligemma, and NVIDIA's Neva-22B. This end-to-end application allows you to not only detect objects and identify locations within images, but also compare results across different AI models to see how each one performs. Whether you're a developer looking to enhance your skills or an AI enthusiast eager to explore the latest in image processing, this tutorial has something for you. Join me as we dive into this exciting project, and by the end of the video, you'll have a fully functional app ready to be used or integrated into your projects. Don't forget to like, subscribe, and hit the notification bell so you never miss out on future content. Now let's do the code walkthrough for our AI-powered image analysis application. In this segment, I'll take you step by step through the code, so you can fully understand how to build and customize this application yourself. Let's dive right in. Importing necessary libraries. We start by importing essential libraries. Requests. Used to make HTTP requests to the NVIDIA NIM API. Base64 helps in encoding the image file in Base64 format. OS allows us to interact with the operating system, especially for environment variables. Load_dotenv loads environment variables from a.env file. Streamlit, the framework we use to build the user interface. Loading environment variables. Here, we use load_dotenv to load the environment variables from a.env file. This is where we store sensitive information like API keys. Defining the image processing function. The process_image function is responsible for making a post request to the NVIDIA NIM API. We pass the image and the user's prompt as part of the payload. Headers. We set the authorization header using the API key from our environment variables. We send the post request to the API and handle the response. If successful, we parse the JSON response to extract the content generated by the AI model. If there's an error, we return an appropriate message. Building the Streamlit user interface. The main function is where we set up the Streamlit UI. Title. We use stTitle to display the title of our application. User input section. We provide a text area for user input with a default prompt asking for the image description and location. Image inclusion option. We add a checkbox to allow users to choose whether they want to include an image in their request. Model selection. We offer a multi-select option so users can choose from different AI models like Kosmos-2, Fuyu-8B, Paligemma, and Neva-22B. Handling file uploads. If the user opts to include an image, we provide a file uploader to allow them to select an image file. Processing the image. We prepare the payload that will be sent to the API, including the user's text input and additional parameters like max_tokens, temperature, and top_. If an image is uploaded, we encode it in Base64 format and append it to the user input before sending it to the API. Sending the request and displaying results. For each selected model, we make a request to the API and display the resulting description along with the uploaded image. Finally, we call the main function to run the application when the script is executed. This code walkthrough helps you understand how each component of the application works, making it easier for you to follow along, modify, or enhance the application to suit your needs. Thank you for sticking with me through this journey of building an AI-powered image analysis application. I hope you found this tutorial informative and empowering. Before we wrap up, let's talk about how you can take this app to the next level and make it your own. Add more models. Experiment with other image understanding models available via the NVIDIA NIM API. By adding more options, you can compare even broader capabilities and find the perfect fit for your specific use case. Enhance user input. Consider adding more interactive input fields. For example, you could allow users to specify exactly what kind of information they want to extract from the image, such as object detection, sentiment analysis, or detailed scene descriptions. Advanced image handling. Expand the image processing functionality. You could incorporate additional image formats, allow multiple image uploads, or even add image pre-processing steps like cropping or resizing. Custom output options. Modify how the results are displayed. You might want to include features like downloadable reports, side-by-side model comparison, or even visual overlays on the uploaded images to highlight detected objects or areas of interest. Deploy and share. Once you've customized the app, consider deploying it on a platform like Streamlit Cloud, AWS, or Heroku. This way, you can share it with your team or the wider community. I encourage you to explore these ideas and make this app truly unique to your needs. If you run into any challenges or have questions, feel free to drop a comment below. I'm always here to help. Don't forget to like this video if you found it helpful, and make sure to subscribe for more tutorials that dive deep into AI, coding, and innovative technologies. Hit the notification bell so you're the first to know when new content drops. Also, if you've built something cool using this tutorial, I'd love to see it. Share your projects in the comments or tag me on social media. Thank you again for watching, and I'll see you in the next video.